Assalamualikum OyaRahmatullahe OyaBarakatuhu. Innal hamdanillah wassalatu wassalamu ala rasulillah. Amma ba'd. Bismillahirrahmanirrahim. This is Muhammad Kamrul Hussain, Department of Business Administration, Metropolitan University, Sylhet. Welcome to my virtual classroom, MKA Classroom. Now let's start today's video tutorial. Today we will start internal rate of return method. You can call it IRR, internal rate of return. This is another sophisticated capital budgeting techniques. So you can see we will use NPV for our capital budgeting decisions, as well as we will use IRR also for our making investment decisions. IRR. Now what is IRR? IRR actually a discount rate which shows NPV equal to 0. So the discount rate that equates the NPV of an investment opportunity with 0 or $0. Or you can say internal rate of return is a discount rate if we use this discount rate for your investment project, where you can discount your expected cash flows, the result will be 0. NPV equal to 0. NPV equal to 0. That rate shows, this rate shows NPV equal to 0. That is such type of rate. So this is the rate which shows NPV equal to 0. That is IRR. Then we will see decision criteria of IRR, or a decision rule of IRR. If IRR is greater than the cost of capital, accept the project, otherwise reject it. If IRR is greater than cost of capital, then we can accept the project. There is very simple rule. If we calculate IRR, if it is greater than our required rate of return or firm's cost of capital, then we will accept the project, otherwise we will reject the project. This criteria generate or guarantee that the firm earns at least its required return. Such an outcome should enhance the market value of the firm and therefore wealth of its owners. That means there is a very important term, that IRR will guarantee that firm at least earn its required return, and its outcome enhance the firm value and enhance the wealth of its owner. That's why that is very important for our decision making purpose. Then we will see calculating IRR. So calculating IRR is not so easy, but you have to look down it very carefully how we calculate IRR. So calculating IRR for an annuity is considerably easier than the calculating for a mixed stream of operating cash inflows. So basically it is easy to calculate the annuity project or annuity cash flows, but it is difficult for mixed stream cash flows. So sometimes problems will provide cost of capital rate or required rate of return, then that is easy for you to calculate IRR. But some project or some issues will not provide you any kind of required rate of return or cost of capital, then it is difficult to calculate. So at that time, for annuity cash inflows, you have to calculate first payback period, and that payback period will be searching in the present value interest factor annuity table, and using that value and project life. That means you have to find out the project life which interest rate will shows the payback period's value. Then it will use that interest rate, such as our payback period is 2 years. So now you have to find out interest rate. So using this two value with the project life in this table, present value interest factor annuity table, and project, if the project life is 5 years, then you have to search in the 5-year period where has the value of 2, as like it is the 10% has the value of 2. So we will discount that cash flows with this 10%. Then we need two NPVs. One is positive NPV, another is negative NPV. We have to calculate two NPV. One is positive NPV, another is negative NPV. So positive NPV, another is negative NPV. Then we need this two NPV. After that we will use these interpolations formula. IRR equal to A plus C divided by C minus D into B minus A. That is the formula for IRR, where A equal to lowest interest rate, B equal to highest interest rate, C equal to lowest interest rates NPV, D equal to highest interest rates NPV. The result would be IRR. So here has the two things. One is positive NPV, another is negative NPV. So whenever you find positive NPV, then you have to search negative NPV. You can enhance the discount rate. Whenever you have the positive NPV, you have to enhance your discount rate by 5% or 10%. You have to increase. So here has the annuity cash in follows. How we calculate IRR using annuity project. After that we will see mixed cash flow, cash in follows, or mixed stream or uneven cash follows. So at first you have to calculate average cash inflow, calculate payback period, find out the interest rate using the value of project life in the PVIF table. Using that interest rate, find out the PVIF table values. So that is another point. So you have to calculate average cash inflow. If you do not use that, not a problem. You have to calculate the payback period, and if you calculate the payback period, you have to find this value in PVIF table. In PVIF table. So if you find that value, you have interest rate. That interest rate you have to use in the PVIF table. So PVIF is for searching table and it is using table. Then we need two NPV. One is positive and the other is negative NPV. After that we will use the interpolations formula, A plus C divided by C minus D into B minus A. Interpolations formula. For is the lowest interest rate, highest interest rate, lowest interest rates NPV, highest interest rates NPV. So we have an example XYZ companies, project A and project B. Here is given the cost of capital. So it is easy for you to calculate. It is easy for you to calculate the project's life or IRR. So if you do not have this cost of capital, then you have to find out the payback period, as like a payback period is 42,000 divided by 14,000. That means 3. Your project life is 5. So you have to search the value 3 in PVIF table. PVIF table with the rate year 5. So we can see in here. So here has our table PVIF table. So you see here PVIF table, our project life is 5 year. Here is the 5 year. Our required value is 3. So you have to search in 5 level where 3 were near about 3. So you see in here 2.9906, 2.9906, that is near about 3. Our desired value is 3. So here is near about 2.9906, near about 3. So our required interest rate is 20%. So 20%, then you can use this 20% for finding the NPV. But in our problem, there has the cost of capital, that is 10%. So we need not searching that matter. So we said that if we have not the cost of capital, then we use that method. Otherwise, that is not needed. So you have to calculate now NPV. You have to calculate NPV for project A. So now we will see the calculations. So here has the project A, calculating the future present value, PV equal to CF into PVIFA. So 14,000 into PVIFA, 10% 5 year. So value is 3.7908. Our present value is 53,071. Now we will see the NPV. So NPV equal to total present value minus initial investment, 53,071.2 minus 42,000. So our NPV is 11,071. So that is a huge amount of NPV. Now we have to search for the negative NPV. So that is our positive NPV. That is our positive NPV. So we have to find out the negative NPV. Negative NPV, we have to find out negative NPV. So as per the guidelines, we have to increase our discount rate. So our discount rate or cost of capital is 10%. Now we have to increase its value for calculating NPV. Now if we try at 20% to find out the NPV, we have to change our discount rate. Previously we have seen that whenever we use cost of capital 10% as a discount rate, we have the positive NPV. So we are searching for negative NPV. That's why you have to increase the discount rate. If at first we find the negative NPV, we have to reduce our discount rate for finding positive NPV. So we have the first positive NPV, so we have to enhance our discount rate for finding negative NPV. So we will change our discount rate to 20%. If we find out this value from our PVIFA table, we will see 2.9906. If you do not understand this system, you can see my previous video finding the present value and future value. So there I am clearing this method. So that is related to this time value of money topic. So if we multiply this, we found 41,868.4. so our NPV should be total present value here as 41,868.4 minus our initial investment is 42,000. Then we will find negative 131.6 taka as our NPV. So we have these two NPV. One is positive, another is negative NPV. Positive NPV shows 11,071.2 and negative NPV shows minus 131.6. Now we will use IRR for our formula, interpolations formula. A plus C minus D into B minus A. So A, lowest interest rate 10%, 10 plus C, lowest interest rates NPV, that is 10% NPV, has the 11,071.2 divided by 11,071 minus D, highest rates NPV, that is highest rate our 20%. So 20% shows negative NPV, 131.6 into 20 minus 10, that means highest interest rate and lowest interest rate. And if we calculate this value, we will found 10 plus 9.88, that's the result. So at first you will calculate in these portions, after that you will multiply with the 10, that is we have 0.988 into 10, that is shows 9.88, and finally add with the 10, that is 19.88% is our project A's IRR. Project A shows the IRR 19.88%. So you can say it is accepted or rejected. So we have the cost of capital 10%. So obviously IRR is greater than cost of capital. So 19.88%, which is greater than 10%. So we will accept the project. So we will accept the project. So a project is accepted. And if you have the comparing problem, so yeah, we can calculate the project B's IRR. So it is the project A's IRR. Now we will see the project B's IRR. We now will try to calculate project B's IRR. Now we will calculate the project B's NPV at a rate of cost of capital 10%. So by the calculating, we will see your cash flows, present value, interest factor at 10%, and present value. So at first we have to calculate the total present value by using the tabular method. 10% we will get this value 0.9091, that is the table value. It will multiply with the 28,000, we will get 25,455. In this way we have the total present value 55,924. So NPV of project B equal to total present value minus initial investment, 55,924 minus 45,000, 10,924. So that is the huge amount of present value, NPV, net present value. So we have to change our discount rate. So at first we will try it for 20%. If the 20% shows the positive, then we will try for 25%. Now we will try for 20%. We will try for 20%. That is our discount rate, discount factor at 20%, 0.8333, 0.6944, 0.5787, 0.4823, 0.4019. So if we multiply this data with our cash flows, then we are getting 23,332. In this way, total present value shows 46,294.2. So our NPV shows total present value minus initial investment, 46,294.2 minus 45,000, it is 1,294. Again we have the positive NPV, so we need a negative NPV. So 10% shows positive NPV, 20% shows positive NPV. That's why we have to again change our discount rate to 25% for finding negative NPV. So that is the problem. So if we calculate 20%, that also the negative NPV, sorry, positive NPV. So now if we try for 25%, 0.800, 0.640, 0.512, 0.410, 0.328. So if you discount this our cash flows, so these are 22,400, and lastly 5 in the year 5, 3,280. So total present value shows 42,580. So if we see the NPV, so NPV shows the negative NPV 2,420, 42,580 minus 45,000, so it shows our negative NPV. So we get our positive NPV and negative NPV. So our positive NPV 10,924 and our negative NPV minus 2,420. So we are getting our desired positive and negative NPV. Now we will use our interpolations formula for finding IRR. So this is our interpolations formula. A lowest interest rate, that is 10%, plus C, lowest interest rates NPV 10,924, divided by lowest interest rates NPV 10,924 minus D, highest rates NPV. Highest rates NPV shows the negative NPV, negative 2,420, into B, highest rate 25% minus 10%. So if we calculate this value, will show at first 10,924 plus 2,420. Now 10,924 divided by this result shows 0.8186. Go multiply with 15, multiply with 15, so it shows 12.28. So it shows 22.28%. So here our IRR shows that 22.28%. So obviously it is greater than our cost of capital. If IRR is greater than cost of capital, then accept the project. So our cost of capital has the 10%, IRR is the 22.28%. So obviously we can accept the project. So here is A project and B project, both project are accepted because both project has greater than cost of capital IRR. So we can if these two are independent project, then we can take all of this project. But if these two are mutually exclusive, then we have to make our rank. So there is the project A and project B IRR. So project B has the IRR 22.28% and project A has 19.88%. Project A has 19.88%. So if these two are mutually exclusive project, then you have to take better one of these two projects. So obviously here has the greater return from project A, that is the rank 1, and B is rank 2. So rank 1 and rank 2, if you rank again in here, rank here 1, 2, so project B and A. So so obviously you will take project B because it shows the greater return than the project A. So if these two are mutually exclusive project, then we will take project B for our decision making, because project B is greater IRR than project A. So obviously these two projects are accepted if these are independent project, but if these two are mutually exclusive project, we will take better one, and better one is B, because by using the ranking approach it will shows that B is the better project. So in this way, if you have several projects A, B, C, D, E, and you can calculate IRR, and using the ranking approaches 1, 2, 3, 4 by the greater IRR, then you can take is the better or best project for your farm. So in this way IRR will help you to making any kind of difficult decisions for your farm. So that's why here are the sophisticated capital budgeting techniques. This all about today. Stay home, stay safe, try to maintain a safe social distance, try to wash your hands frequently in a day. Subhanaka Allahumma wa bihamdika ashhadu an la ilaha illa anta astaghfiruka wa atubu ilaika. Assalamualaikum warahmatullahi wabarakatuhu.